Antenna and microwave domain. Satellite TVs are oriented to the satellite dish in a particular direction for best reception. Thanks to the satellite communications, we can view live matches from across the world. Are you carrying an antenna with you? Yes. People are carrying one or more antennas with them wherever they go. Guess which? It's a mobile phone. This significant rate of growth is not likely to slow as wireless communication systems become a larger part of everyday life. In addition, the strong growth in RFID devices suggests that the number of antennas in use may increase to one antenna per object in the world. This number would reduce the number of antennas in use today. Hence, learning a little about antennas couldn't hurt, and will contribute to one's overall understanding of the modern world. First off, let's remind everyone that microwave electronics are by and large an analog science, as opposed to most other electrical engineering, which has mostly gone digital. We think of analog as real life, and digital as the reality TV of electronics. No one really listens to digital music or sees digital television. Your senses are analog. Digital communications must be carried on an analog radio signal. Analog engineering will never go away. Let us know a bit more about antennas. Its efficiency. The efficiency of an antenna is a ratio of the power delivered to the antenna to the power radiated from the antenna. Efficiency is one of the most important antenna parameters. It can be very close to 100% or 0 decibels for dish antennas. Mobile phone antennas or Wi-Fi antennas in consumer electronics products typically have efficiencies from 20% to 70%, -7 to -1.5 decibels. Major classification of antenna includes 1. Yagi-Ura antenna, 2. Horn antenna, 3. Antenna array, 4. Parabolic reflectors, and 5. Patch antenna, which includes PIFA, the heart and soul of any mobile device. The signals transmitted by an antenna are called as the microwave signals. We define it as an electromagnetic wave between 300 MHz and 300 GHz. Microwave components and systems are a multi-billion-dollar industry. The design community is small. Perhaps only about 50,000 to 1 lakh people consider themselves in the microwave field. What are the big 3 applications of microwaves in everyday life? Heating, remote sensing and communications. Heating applications. The common application and mostly used in daily life is the microwave oven. Remote sensing. The most well-known remote sensing systems are radars, radio direction and ranging, which use a transmitter to illuminate an object, and a receiver to detect its position or velocity, or both. Communications applications. Communication systems include satellite, radio, television, wireless phone and data transmission applications, and all combinations of these. Commercial applications of microwave technology include the front end of much of the wireless stuff you use every day, such as cell phones, pagers, wireless LANs, satellite television, etc. Remember, without antenna there cannot be communication. Antenna engineer responsibilities and duties include design, create and implement antenna system solutions in order to improve the performance of communication systems. Design antennas for complex 2G, 3G and 4G wireless communication applications. An engineer working in the area of microwave antennas spends their time designing, developing, and testing the components of a microwave antenna system, including the reflector, array systems, transmitters, receivers, frequency synthesizers and circuits. The microwave antenna engineer may also be involved in technical analysis, design improvement and laboratory testing. Microwave antenna engineers work mostly indoors but may have to perform outdoor site visits. ISRO, SAMEER, DRDO, and many more small-scale industries use antenna engineering.